Doing question number 1 from section 7.3, which is trig substitution. And the question asks us to solve the integral of dx over x squared times the square root of 4 minus x squared using the trig substitution x equals 2 sine of theta, and to also draw the triangle we used to get this back into terms of x. So what we're going to start off by doing right now is seeing which part of the integral we have and which part we need to solve for before we go taking the integral. So we don't know dx, which is something we can actually find, because we know dx is just the derivative of x. So dx is going to equal the derivative of sine, which is cosine of theta, and 2 is just a constant, so it's going to stay along for the ride. So we get dx is equal to 2 cosine of theta. Now we know x squared because that's just taking x, the quantity of x, and squaring it. And we can actually simplify the square root of 4 minus x squared before we go solving the integral. So we have the square root of 4 minus x squared, which we can simplify by plugging in an x. So we get 4 minus 2 sine of theta squared. Now we can square this out and we get 4 minus 4 sine squared of theta. Now, we can't take the square root of this as is, but we can simplify it and take the square root of it by taking out a 4, because we have a 4 in this term and we have a 4 in this term. So this equals the square root of 4 times 1 minus sine squared theta. Now, we know from our trig identities that 1 minus sine squared theta is the same as cosine squared theta, which we can take the square root of. So I'm going to sub this out for cosine squared theta. So this is going to equal the square root of 4 cosine squared theta, which when we take the square root of, we get 2 cosine of theta. So now we have all the parts that we need to go ahead and solve this integral. So what happens when we plug it in is we get the integral of dx, which we found here to be 2 cosine theta, cosine theta, over x squared, well, which we can do by just taking that quantity squared, so that's going to be 2 sine of theta squared, times 4 minus x squared, which we solved here and got 2 cosine of theta. So we're going to plug that in here. Okay, now before we go to solve the integral, we see that we have a 2 cosine theta in the numerator and a 2 cosine theta in the denominator, which will cancel. So we can actually get rid of that right now before we go ahead and continue solving. So now when I simplify this, I get 1 over, if I square this quantity, I get 4 sine squared theta. Now it'll be a lot easier to solve the integral if we didn't have this 4 here and this 4 here, and we can actually take that out by taking out a 1/4. So we can take this out of the integral because it's the same as multiplying by a 4th. So 1/4 integral of 1 over sine squared theta. Now, we have this 1 over sine squared theta, but we can actually simplify it into something that's a little bit easier to take the integral of. So we know that, I'll do it over here, we know that 1 over sine of x is equal to cosecant x. So by that logic, 1 over sine squared x is going to equal cosecant squared x. And in this case, we're using theta, so this would be 1 over sine squared theta equals cosecant squared theta. So now what we have is we have 1/4 times the integral of cosecant squared theta, which we can't take the integral of, and that equals 1/4 times negative cotangent theta. Now, this would hypothetically be our answer if it was in terms of theta, but it's not. It needs to be in terms of x. And to get it in terms of x, we're going to draw the triangle, which is this second part of this question. So we're going to draw the triangle here and use the parts that we do know to find out our cotangent. So I'm going to label this theta. Now, we're going to actually be able to solve for the sides of the integral based on the original x they gave us. So we know x equals 2 sine theta. So that means sine of x over 2, or x over 2, is equal to sine of theta. And we know sine is opposite over hypotenuse. So using our theta, we're going to take the opposite, which is x, and then we're going to go to the hypotenuse, which is 2. Now, by the Pythagorean theorem, we'll get 2 squared and x squared, and this side is going to equal the square root of 4 minus x squared. So now we have our theta and we have all three sides, so we can actually find out what cotangent of theta is. So what we're going to have is 1/4 times negative cotangent theta. So 1/4 cotangent. What we're going to have is we're going to have negative cotangent. So cotangent is adjacent over opposite. So our adjacent here is the square root of 4 minus x squared, and our opposite is x. So now we have it in terms of x. So when we simplify this, we get negative square root of 4 minus x squared over 4x plus c. And this is our answer in terms of x.